Good morning, my dear students. Welcome back to D and F block elements. So in this class, I'm going to discuss very important concept, that is atomic and ionic radii. Okay. So tell me now, what happens from left to right? From left to right in the periodic table, what happens to the radius? General, already you have studied in the periodic properties, right? So from left to right, atomic size decreases, and down the group atomic size increases. Okay, this is in general. In generally, from left to right, radius decreases, top to bottom radius increases. Okay, this in general. Okay, but there are some exceptions in this. Okay, that I'm going to discuss now. Okay, right. Chalo. So before we discuss this atomic radii and ionic radii, I'm going to tell you one important concept, that is effective nuclear charge as well as screening effect. Look at here. So suppose there is a nucleus like this, and there is outermost electron here. Okay. So suppose there are inner electrons. There are some inner electrons. There are some inner electrons. Okay. Very few electrons inside. Okay. Then what happens? So there is one more case, case 2. ठीक है, इसमें outer electron भी है, but inside there are number of electrons. There are many electrons here. There are many electrons. These are the two possible cases. There are two possible cases. ठीक है. So what happens here? What happens here? What happens? So here now tell me now, in which case, this is a case 1, a case 2. Take it. Tell me now, in which case the effective nuclear charge is more, and in which case electron repulsion is more. Which case? Look at here. Abhi beech mein kya? There are many electrons inside. This is outermost electron, and inside there are many electrons. Okay. So if there are many electrons inside, what happens now? Will it attract the outer electrons? No. They will protect the outer electron from the nucleus. So these electrons will screen the outer electron from the nucleus. It will screen, means it will protect the outer electron. Yes or no? So meanwhile, what happens? Electron repulsion takes place, right? If there are many electrons inside, what happens now? Electronic repulsion takes place. ठीक है, electronic repulsions takes place. अभी इसमें electronic repulsions. Electronic repulsions takes place. So due to this electronic repulsions, this electron will it come inside or will it go outside? To get the stability, to minimize the repulsions, what it will do? It will move away from the nucleus. It will move away from the nucleus. So what happens now? Size क्या हो रहा है? Size increases. Size increases. So what happens? The radius also increases. Radius also increases. And what about here? इसमें अभी inner electrons less. अभी now this effective nuclear charge will dominate now. Now this effective nuclear charge, what it will do now? It will attract the outermost electron inside. ठीक है, it will attract, जो अभी इसमें electrons कम है, अभी क्या करते हैं? effective nuclear charge, it will attract the outermost electron inside. ठीक है, so what happens now? अभी electron will come inside. Electron will come inside. So what happens to the size now? इसमें effective nuclear charge ज्यादा है ना, इसमें effective nuclear charge is more. So what happens now? It will attract the outermost electron inside. So अब इसमें क्या होता है? Size decreases. Size decrease में increases, इसमें decreases. So what the size decreases? Because of effective nuclear charge. Because of effective nuclear charge. Here size increases because of electronic repulsions. It is nothing but screening effect. Outer electron is screened from nucleus by inner electrons. So it is size increase due to screening effect. Electronic repulsions, it is also called as screening effect. Screening effect. Screening effect, and it's effective nuclear charge. Now tell me now, due to effective nuclear charge, size क्या हो रहा है? Size कम हो रहा है. ठीक है. Due to screening effect, size क्या हो रहा है? बढ़ रहा है. ठीक है. Now tell me now, from scandium to manganese. From scandium to manganese, what is happening to the number of protons, means number of protons क्या हो रहे बढ़ रहे, atomic number increasing, मतलब number of protons increasing, so effective nuclear charge increasing. ठीक है, at the same time electrons also increasing, no, at the same time electrons also increasing. So what happens now, effective nuclear charge increases, no doubt, but at the same time number of d electrons also increases, so screening effect also increases. ठीक है, but one will decrease the size and the other one will increase the size. So tell me now which one we have to take now, which one we have to take now. Both are increasing from left to right, both are increasing, effective nuclear charge increasing, at the same time d electrons also increasing. ठीक है, so which one we have to consider now, we have to consider both. From that is why from scandium 2, that is why from scandium, अभी relation लिखो, पहले relation लिखो, radii are size whatever it is, radii is directly proportional to screening effect. Screening effect मतलब electronic repulsions. Okay, electronic repulsions, electronic repulsions. ठीक है, inversely proportional to Z effective nuclear charge. What is effective nuclear charge? The effect of nucleus on the outermost electron. If there is more effect, more attractions, that will bring inside. The nucleus will pull the outer electrons inside, खींच the electrons को. So size क्या हो रहा है, कम हो रहा है. ठीक है, so from left to right ये भी बढ़ रहे, ये भी बढ़ रहे. If it increases वो decrease होते, if it increases ये increase होते. ठीक है, now which one we have to take, that is why we have to take the net effect, both we have to consider, both effect we have to consider. ठीक है, so देखो अभी from scandium 2, from scandium 2 manganese, from scandium to manganese, from scandium to manganese, radii decreases, why? Because here effect a number of d electrons less, no, from scandium to manganese number of d electrons increases. ठीक है, but pairing नहीं होता ना, so repulsion is not dominated. So what happens now, Z effective will dominate, screening effect. ठीक है, अभी कौन डोमिनेट करते, effective nuclear charge डोमिनेट करते. So from left to right effective nuclear charge increases. So if the effective nuclear charge increases, radii decreases, इसलिए decreases. ठीक है, next, but from manganese to copper, radii remains constant, approximately constant. There is no much change, there is no significant change, only very insignificant change. ठीक है, so radii is almost constant. Why? Because both are same. That means effective nuclear charge and this one and a screening effect दोनों भी सेम रहते, स्क्रीनिंग इफेक्ट दोनों भी सेम रहते, इसलिए there is no much change in the radii, almost constant. And from, but look at here, from copper to zinc, radii increases, what is the reason? इसमें कौन डोमिनेट करता है, भी देखो, screening effect dominates. Look at it, in zinc there are D10 10 electrons, very क्या बोलते इसका, many electrons. In d orbitals there are many electrons. ठीक है, so due to many electrons, due to more number of electrons, screening effect will dominate, इसलिए screening effect will dominate here. means electron repulsions will dominate. Screening effect dominates effective nuclear charge. इसलिए size increases, it dominates. So size more the screening effect, more the radii. ठीक है, इसलिए radius increases from copper to zinc. ठीक है, so this is observed in 3D series. ठीक है, right? So same observation in 4D as well as 5D. Same, दोनों भी same. ठीक है, but top to bottom from down the group always number of cells increase. No, when the number of cells increases, radii increases. ठीक है, so no doubt increases, but there is one condition here. Condition मतलब कैसे? Look at here, top to bottom, down the group, no doubt down the group size increases, but not regularly. Increases but not regularly. Now it's a regular trend, it will not follow a regular trend. Why? Because look at here, from 3D to, look at here, write down this, from 3D to 4D, there is a significant there is significant increase in the size. There is significant increase in the size. ठीक है, from 3D to 4D there is a significant increase in the size, but from 4D to 5D there is insignificant increase in the size. Insignificant increase in the size. Insignificant increase in the size due to poor shielding of electrons. Look at here, in 5D series, after lanthanum there are 14 F electrons. So hafnium onwards there is sudden drop in the size. ठीक है, there is sudden decrease in the size due to poor shielding F orbitals. ठीक है, अभी this F electrons they do not protect the outer electrons from the nucleus. ठीक है, yesterday I told you already. So F electrons due to these poor shielding F electrons, due to this poor shielding F orbitals, they do not protect the outer electrons from the nucleus. अभी this F orbitals क्या करते हैं अभी, sorry, this nucleus क्या करते हैं अभी, it will attract the outermost electron inside. ठीक है, so there is sudden decrease in the size. That is why size increases, but it is very insignificant, not considerable increase in the size. So 4D as well as 5D elements, they will have approximately same size due to lanthanoid contraction. Due to lanthanoid contraction, there is no much increase in the size. Okay, right. So what is the graph of this now? It is given in the NCERT book. Okay, so what is this? It is radii. Okay, what is this? It is radii and it is atomic number J. Okay, from left to right. इसके scandium है, ठीक है, zinc, sorry, it is manganese and it is copper and एक है zinc. ठीक है, so first I am going to tell you the 3D series elements. ठीक है, from scandium to manganese. क्या होता? Size decreases, like I say, size decreases. But from manganese to copper, from manganese to copper size there is no much variation in the size because both okay, effective nuclear charge and screening effect both are operating at equal magnitude, इसलिए there is no difference in the size, approximately they have same size. And from copper to zinc what happens, size increases. From copper to zinc size increase, why? Because of electronic repulsions, मतलब screening effect will dominate effective nuclear charge. So from copper to zinc size slightly increases, but from manganese to copper size approximately same, and here to here size decreases. Size nothing but radii. So this is 3D, बट वेर इट 4D. अभी देखो क्या है, स्कैंडियम. नेक्स्ट वन कौन सा, अभी बोलो. स्कैंडियम सब क्या है, इट्रियम. नो इट्रियम. ये वाला क्या है, मैग्नीज टेक्नीशियम. ये क्या है, कॉपर सिल्वर कैडमियम. ठीक है, सेम ऐसे होता है इधर भी. बट व्हेन अभी देखो रेडी इंक्रीज डिक्रीजेस फ्रॉम 3D to 4D, देयर इज सिग्निफिकेंट इंक्रीज. there is a significant increase in the radii from 3D to 4D. 3D to abhi 4D I am writing here. Okay, 4D I am writing here. So there is a significant increase in the radii like this. Same from here to here a value. ठीक है, ये copper है, ये क्या है, कौन सा, a technetium है, ये क्या है, a silver है, and then sudden increase due to lanthanum, due to screening effect. ठीक है, ये क्या है, 4D series elements. and then lanthanum. एंड ये क्या है, इधर ऑफनियम रहते, हाफनियम रहते इसमें. ठीक है, एंड इधर क्या रहते, स्कैंडियम. ये क्या है, टाइटेनियम. स्कैंडियम टाइटेनियम, इसमें टाइटेनियम जिरकोनियम हाफनियम. ठीक है, इसमें क्या रहते हैं, 14 F इलेक्ट्रॉन्स आर प्रेजेंट. ठीक है, स्कैंडियम टाइटेनियम वेनाडियम. ठीक है, ओके, so not so on. I'm not writing all the elements, I'm writing some elements. okay, right, so on. ठीक है, राइट, सो ऑन. नेक्स्ट क्या है, मैंगनीज टेक्नीशियम. अभी क्या है, इसमें रेनियम आएगा, इसमें क्या है, गोल्ड आएगा, इसमें मर्क्यूरी आएगा. ठीक है, सो अभी क्या है, 4D. इट इज 3D एलिमेंट्स, ए 4D एलिमेंट्स, ए 5D एलिमेंट्स. सो 3D to 4D साइज इंक्रीज इज सिग्निफिकेंट इंक्रीज इन द साइज फ्रॉम 3D to 4D, significant increase. But 4D to 5D size increases but slightly, that is insignificant increase in the size due to lanthanide contraction. अभी lanthanum को ज्यादा रहती है when compared to yttrium, because इसमें lanthanum में f electrons नहीं, f orbitals नहीं. ठीक है, इसमें no lanthanide contraction in lanthanum. after lanthanum there is a lanthanide contraction. इसमें lanthanum में lanthanide contraction नहीं, तो ऐसे रहते, ऊपर रहती थोड़ा. ठीक है, sudden decrease like this. okay, it is 5D. okay, right. So look at here, these elements are same. So due to lanthanide contraction, very important my dear students, it is very important. Due to lanthanide contraction, what happens, the radius of zirconium and hafnium, it becomes same. It is same, approximately same. Zirconium and hafnium have same radii. and also इसमें क्या होता है, अभी नेक्स्ट एलिमेंट क्या है, टाइटेनियम, वेनेडियम, नो नियोबियम टांटलम. ठीक है, राइट. so due to lanthanide contraction, the radii of zirconium and radii of hafnium, they are same, approximately same. simple, इसमें कुछ भी नहीं. देखो, the respective elements of 4D and 5D, they will have approximately same size. बस the corresponding elements, मतलब zirconium, hafnium. इसमें क्या है, नेक्स्ट एलिमेंट क्या है, नियोबियम एंड टांटलम. radius of नियोबियम equal to radius of टांटलम. नेक्स्ट कौन सा, वेनाडियम. नेक्स्ट वेनाडियम के बाद क्रोमियम मोलिब्डेनम टंगस्टन. so tungsten and molybdenum, they will have same, approximately same radius. so this is very important my dear students. the radii of 4D and 5D series elements are approximately same. ठीक है, but corresponding elements, okay, the respective elements, these two, these two pairs, the pairs are stable, same radii, same radii. So these are same radii. Okay, so this is the graph of radii versus atomic numbers, atomic elements. Okay, so this is atomic radii. Okay, but what about ionic radii? Ionic radii, what is ionic radii? Ionic radii. Now tell me now, when compared to the atomic radii, ionic radii is more or less? Obviously less. Why ionic radii is less? Because which ions will they form? The d block metals will form cations. The d block elements will form cations. Okay, always remember cations. Okay, a cation is neutral atom and it is anion. Okay, which is having more size, more the positive charge, small less the size, less the size, less the radii. Because look at here, more the positive charge, abhi effective nuclear charge is more. If the effective nuclear charge is more, it will pull outer electrons inside, so size decreases. अब इसमें electronic repulsions are more, इसमें screening effect is more, so what happens? Size increases. So which is more in size now? Anion का ज़्यादा है, and then neutral and सबसे least cation का size. So ionic radii, so d block elements, in d block elements, ठीक है, atomic radii, atomic radii is, atomic radii are more than ionic radii, ionic radii, ionic radii for d block, for d block elements, for d block elements. For d block elements, atomic radii is more than, atomic radii is more than ionic radii, because d block metals will form cations. ठीक है, because for example एक example discuss करेंगे, metal, so what, take one any one metal, ठीक है, manganese, ठीक है, atom, atomic radii, ठीक है, and it is Mn+2. what is this? Ionic. So which is more radii, which is more radii, which is more? Always manganese has more radius than Mn+2. ठीक है, atomic radii, in this case atomic radius is always greater than ionic radii for d block elements, because positive charge. What is the relation between, what is the relation between charge as well as and the radii? Radii is inversely proportional to charge, means oxidation state, oxidation state. More the oxidation state, less the size. ठीक है, oxidation state means positive charge, positive charge. ठीक है, positive means oxidation positive charge होना चाहिए. More the oxidation state, less the size. Now tell me now, arrange them in decreasing order of their size. Mn+2, Mn+3, Mn+4, Mn+5, Mn+6, Mn+7. ठीक है, so arrange them in decreasing order of their radii. Radii किसको ज्यादा रहते? radii किसको ज्यादा रहते? बोलो. More the charge. If there is more charge, more oxidation state, more the oxidation state, less the radius, less the oxidation state, more radius. ठीक है, now tell me now, ये बराबर ना? Correct no? This is correct. This is correct. And what about this one? Radii of this one. Tell me. Cr+2, Cr+2, and Cr+3, and Cr+4, Cr+5, Cr+6. Among them, which is least radii, +6. More the oxidation state, less the radius. Simple. ठीक है, so अभी क्या है? इसकी ज्यादा है. Radii is more for chromium+2. Simple, ये ध्यान में रखो. More the radii, more the oxidation state. तो क्या है? More the oxidation state, more the effective nuclear charge. More the effective nuclear charge, less the radius. Plus. Okay, right? Understand? Right. So in the next class, we will discuss ionization energies. Ionization energies. Okay. So this is about radii. In the next class, we will discuss about ionization energies. ठीक है, in examination I'm giving up to ionization energies. ठीक है, tomorrow there is this coming Sunday exam, right? Coming Sunday exam में क्या tomorrow syllabus में रहते, ठीक है, right? Ionization energies up to ionization energies. Okay, right. Thank you very much.